So in the last class, we discussed two classifications, analog versus digital signals and periodic versus aperiodic signals, right? And towards the end, I gave you some problems. Anybody tried to solve the problems or anybody having some doubts in the problems? Because those types of problems will come in the examination. Okay? Any doubts regarding the solved problem? That is the problem which is solved in the class in a hurry? No doubts.
Sir, question number 8, sir. Sir,
Question number 8. Which one? Can you say the question? Cos 2 pi t plus cos 3t.
The cos 2
sir,
pi t plus
cos 2 pi
0.5 cos
t
5 pi t.
plus 0.5 cos 5 pi t.
Okay. What is the problem you faced? What is the difficulty you faced? Yes. Did you try to solve it or means you are stuck from the beginning? Hello? And who asked this question?
Sir, me, sir. 45. Roll number 45.
What was the difficulty? Did you start, did you stuck in the middle or you were not able to start the problem?
Sir, in the middle I stuck.
Okay. So what I'm going to do is to review those problems. Okay. Very quickly. So problem number 1 which solved is very easy, right? Okay. Then problem number 2 was, so problem number 2. What was it? Sine cube of 2. Have you solved this? What was the period? Is it periodic first? Okay. What was the period? Yes. 1 by pi second. Okay. So it is periodic. With period. One by pi second. Who was not able to solve this? Is there any person over in the home or at home who was not able to solve this? Everybody solved this?
Yes, sir.
You can say whether you have difficulty with this. Okay. So if nobody has any problems with this, let us go to number 3. What about number 3? E to the power minus 2t cos 2 pi. Is it periodic or aperiodic? Any answers? Did not solve, right? Aditya, did you solve? Suman? No. Okay. Why did not you ask this question? Okay. Anybody from home solve this?
No, sir.
What is your answer?
Sir, I couldn't solve it, sir.
Sorry?
Sir, I couldn't solve it.
Okay. Anybody else who solved it? So, we are going to solve this by plotting it. Okay. So, what is cos? Cos 2 pi t is periodic, right? Like this. Okay. But I have multiplied this with e to the power minus 2. So, that means that earlier its amplitude, if I just write cos 2 pi t, what is its amplitude? Other way I will put cos 2 pi. What is the amplitude of this? What do you mean by amplitude? What do you mean by amplitude? Yes, maximum this one. Okay, what is this? If I just write cos, it's 1, right?
1.
That is that whatever I write over here is the amplitude. So here I have not written anything. I have written 1, right? 1 into cos. So that is the amplitude. So instead of 1, if I write e to the power minus 2, that means now this is the amplitude, right? So earlier, so if I draw this amplitude over here, and so highest value is 1 and lowest value is -1, right? So amplitude and minus of amplitude. The curve stays in between, right? So right now I am going to draw e to the power -2 and minus of e to the power -2, just like 1 and -1. When the amplitude was 1, I draw 1, I draw -1, the curve stays in between. Now amplitude is e to the power -2. So I am going to draw e to the power -2t, minus of e to the power -2t, and the curve will stay in between. E to the power -2t is a decaying exponential. From network theory, you must be knowing what is decaying exponential, right? So it will be like this. E to the power -2t. At t equals 0, what is the value? E to the power -2. Sorry.
0, 1.
E to the power 1. So 1, and it goes like this. Its slope depends on this -2 value. Okay. And also over here, -1, and it goes like this. And the rate of decay you can find out from this. Okay. So this curve is e to the power -2t, and this curve is e to the power minus of e to the power -2. And now the cos will start from here, and it will be like this, right? Does it look like a periodic signal? What is the definition of periodic signal? But here you can see that here you are observing that as in progressive time, the amplitude is constantly decreasing, right? That means that no part of the graph is going to repeat because it's constantly decreasing, right? So compare this. That's this is the highest point in this portion of curve, and this is the highest point. Even if they look similar, the S because because of multiplication of e to the power -2, this value is lower than this. That's why this is not the same height as this, right? So that means that
Your voice is not clear.
is my voice now clear?
Now it's clear.
Now it's clear, right? So yesterday I attached this in my pocket, so it was better distance to my mouth. Right now I have put closer to my mouth. So if it is still not clear, then you point it out. Okay.
Okay, sir.
So is it not clear? Is my voice not clear? Is it same as last time, last class? Or is
It's
there any-
clear, sir. Now it's clear from last class.
Okay. So I hope that my voice is clearer from the last class. Because the last class I observed the recording, as I have said, it was not very clear. Okay. So what I was saying is that although this is the crest of this point is the crest in this part of the curve, and this point is crest of this point of this portion of the curve. But this point and this point have different amplitudes. That means that this waveform is not repeating itself. That's the point. Okay. At no point this waveform will repeat itself. It's constantly going down. Okay. So this is aperiodic. No need to calculate its period. Okay, because it's aperiodic. Is it clear who are staying at home?
Yes, sir.
Aditya?
Yes, sir.
So is it clear? Is my voice clear?
Yes, sir. Voice
yes,
clear.
sir.
Okay, so anything else you want to say about whether blackboard is visible or not visible?
Yes, sir. Blackboard is visible, sir.
Okay. So did you understand this problem, Aditya? Aditya,
Sir.
did you understand this problem?
Yes, sir.
Okay. The point is that this waveform is unlike this, where it is amplitudes are constant, it's decreasing, so it no at no point it will repeat itself. That's why it's separated. Next point, next problem. So next problems I'm not going to do very easy. So number 4 xn equals -1 to the power n. What is the answer for this? It will not do. Did not get. It's very easy. You just vary your n. You find the value of x0. Give me the value of x0. All of you, give me the value of x0 if xn is this. That means put n equals 0. So -1 to the power 0 is 1. What about x1?
-1,
-1. x2,
1,
1. x3.
-1.
So this pattern will repeat. You can plot it. You can see that this thing. So 1 and -1, 1 and -1 like this. So that means that whatever is at x0 will repeat itself at x2 and will repeat itself at x4 like this. That is at this periodic, and this period what? Period is equal to
2.
2.
2.
Hello? Do you hear me?
Yes,
Yes,
sir.
Yes, yes, sir.
Yes, sir.
Okay, because of some UPS issues, the meeting means this side the computer went off. So let us start again. So all the people who were here, all of you are here, na? Nobody left.
No, sir. No, sir.
Okay, so I was going through this one, this problem xn, which is equal to -1 to the power n. We found out after putting values of n 0, 1, 2, 3 that it gets repeated after 2 samples, right? So that means that it is periodic with a period of 2, but in this case it's not seconds. Periods is not seconds, it is samples. Why? Because discrete signal is a collection of samples. The x-axis we are taking samples, right? So that means that if we are going to plot this, is it visible this place? Okay. So if you are going to plot this, then you are going to get 1 over here, -1 over here, 1 over here, -1 over here, like this, right? So the signal is like this. So that means that if this is n axis, this is xn axis, this is 0, 1, 2, 3, 4. So all these are values of n, and all these are samples. So the period is this up to this. This is the period. So capital N is equal to 2 samples. 1 sample, 2 sample, right? So similarly, the next one you can do. So for the sake of saving some time, you should also note that the number 5 is xn -1 to the power n square. Do it like this and you will find the same answer, right? That it is periodic with period 2 samples. Okay, I'm not doing it. Next one, cos 2n. So number 6 is, what about the signal xn equals cos 2n? So as it is a cos function, one may suspect that it is periodic, but it is not. So the issue with discrete time sinusoidal signals is that the discrete time sinusoidal signal like cos and sine may or may not be periodic, even if it is cos and sine. Okay, so over here, what is if it let us treat it as periodic. If it is periodic, then what is the tentative, right? That is the word, tentative. Tentative means if it is periodic, what is the fundamental period? How to calculate it? If it is periodic, then what is the tentative fundamental period? Tentative means what? Means what is the at present, if I treat it as periodic, what is the fundamental period? That's why I've written the word tentative. Finally, it may turn out to be not to be periodic. That's why the word tentative. So tentative fundamental period is what? If you compare this with cos 2 pi n, 2 pi fn, sorry, 2 pi fn. Yes? Yes. So if you compare this with this, then what is f?
1 by pi.
So 2 pi f is equal to 2, right? That means that f is equal to 1 by pi. That means that t, which is 1 by f, is pi. So tentative fundamental period is pi samples, right? But so you need to now check that whether this number is an integer or not, because the discrete time signals is only defined for integers. If I have a value of time period which is pi, which is not an integer, that means that this is not a periodic signal, because pi is not an integer and discrete time signals is only defined for integers at 0, 1, 2, 3, 4, 5, like this. This n is only defined for integers. So if you find the period as this is not an integer, so that means
Sir,
that
that side is not visible.
Okay, that side is not visible. So this is not an integer, right? Up to this you have seen this is visible?
No, sir.
No.
No, sir.
Is it visible?
Yes, now.
Okay, so here I have found out the time period to be pi for this case. Okay, so which is not an integer, that means that this is not periodic. Did everybody understand?
Yes, sir.
Yes, sir.
Okay, so likewise the next problem number 7, which was given slightly different from this, cos 2 pi n. Now I include this pi. Okay, if I include this pi, then what is the tentative fundamental period for this case? If you can now compare 2 pi n with 2 pi fn. So let me delete this question. Okay, and yes, so now I need to compare 2 pi f with 2 pi, right? So 2 pi f with 2 pi, which will make this as 1, right? And which will make this as 1, and which is an integer, right? Now it is an integer, so it is periodic. So it is periodic with period equals what? Period कितना आया?
One samples.
Period कितना हुआ? 1. So one sample. Okay. So likewise, you are going to get some problems. You just compare with this format and see, for this kind of problems, number 6 and 7. Then you check whether the period which you are getting is integer or not. If it is integer, then it is periodic like this, and if it is not, then it's not a periodic signal. Okay, next one. Okay, next the point is number the next two problems, which are sum of two cosines and sines. Yes, two cosines. Those are important questions. Okay, because those are the kind of questions where in examination that will those kind of questions will come. Okay, number 8, right? So number 8, xt equals cos 2 pi t plus what is it, 0.5. So I'm just going to do number 8. Number 9 you do it by yourself. Okay, 0.5. No, because I have a point to make in number 9 also. Okay, so I'll also do that one. Cos 2 pi t. This is the question. Yesterday I gave you a this note where I talked about period of sum of periodic signals, right? What will be the period of sum of periodic signals? So in this case, you find that this is periodic and this is periodic. Now let us speed up the process, okay? Because we are lagging behind, because we need to speed up, cover the course. So I find that xt is a sum of two periodic signals. What is the period of this one? It's very easy. This is now again we are in the continuous time domain. Okay, what is the period of this?
1 second.
This is what? 1, right? 1 second. And what is the other one? What is the period of this one? 1 again, because over here only the amplitude changes, right? Here it is 1 and here is 0.5, but no change in frequency or period. So here the period is, so let us call it as period t1, and here period t2. What is the period? Is it sorry, is it the question which I gave? It was 5, not 2. Okay, Now, if it is 5, then what is the period? Sorry, 2 pi by 2 by 5. 2 by 5 or 1 by 5. You can give me exact answer. 2 by 5, right? 2 by 5. Okay. So means you need to compare with 2 pi f with 5 pi. That means that f is what? 5 by 2, right?
5 by 2.
That means that t is 2 by 5. Okay. So 2 by 5. Okay. Let it remain as 2 by 5. All of you understood at home?
Yes, sir.
So
Yes,
the first signal has time period 1 second and the second signal has time period 2 by 5 second. But what will be the effect of the addition of those two? First,
LCM
before
of both these
so before checking the LCM, you need to check whether these two numbers, the ratio T1 divided by T2, whether it is rational number or not. If it is not rational, then straight away aperiodic. If it is rational, then go on find the LCM of those two numbers, and that will be the period. All right. So what is T1 by T2 in this case? T1 is
5 by
1
2.
divided by 2 by 5, which is 5 by 2, which is a rational number, right? So this is a rational number, which means that xt is periodic. So what is so this is periodic with period
5 by 2.
with period else, which is LCM of T1 comma T2, right? So what is the LCM of that?
2
LCM
by 5.
of 1 5 by 2. What is the LCM of 1
Sir,
comma
T2
5 by
is
2?
2 by 5, na? T2 is 2 by 5.
Yes, 2 by 5, not 5 by 2, 2 by 5. So what is the LCM of those two numbers?
2 by 5.
Find out the LCM, is least common multiple. 5. Are you getting 5? Okay, so if I multiply 5, then if I multiply 5, no. So if I multiply 5 with this, means so yes, so that means that what is the 1 into k equals 5, right? What is the value of k? 5. And 2 by 5 into something k2 equals 5. So what needs to be over here? How much I multiply? How much? 12 by means how much should I multiply 2 by 5 to get 5? If the answer is 5, so what is the factor? Yeah,
5 by 2.
12.5. 12.5. Okay, 12.5 is what in terms of fractions? 25 by 2.
25 by 2.
Okay, 25 by 2. Yes. So the LCM is 5, right? Okay. No, but it's not right. This needs to be a integer, right? How to find LCM? How to find LCM of this and this? So, yes. 1 comma. Okay. LCM will be 5. So what is this 2 by 5 in fractions? 2 by 5 in fractions. Means 2 by 5 is 0 point something, right? What is that value? 0.4.
Sir, 0.4.
0.4, right? 0.4. So I am seeking something. So I am seeking what? 1 into K1 which will be equal to 0.5 into K2, and K1 and K2 is an element of natural numbers or positive natural numbers n plus. That means these needs to be K1 and K2 needs to be integers, right? So what is the value? 5. So if I take K1 as 2 and K2 5, those will be equal to what? 2, right? So 0.4 into 5 is 2 and 1 into 2 is 2. This is the least common multiple, right? The least integer which you multiply with this and this to get a common answer, equal answer. So I have also slightly forgotten how to calculate LCM, right? But this is the way, means you can calculate, right? So the answer is, so this is the answer. So if you do LCM of this and this, you will get not 5 but 2. 5 is the multiplication factor, right? All of you understand? The point is here, the point is not to dwell upon how to find LCM, but it is the answer to this problem is the LCM. So you need to find how to just remember how to find LCM, and that is the answer. Okay. So LCM of this and 1 and 0.4, which is equal to 0.4 is equal to 2 by 5 is equal to 2. So all of you who are at home, did you understand this? How to calculate, means the answer is LCM, right? Answer is LCM. So you need to just remember how to calculate LCM, right? Other than that, there is no big means there is no rocket science here. Just need to calculate LCM. Okay. So people at home, are you confused about how to find LCM? So I think slightly over here. So LCM will turn out to be 2. People at home, did you understand?
Yes, sir.
So you need to calculate LCM, and in this case, it turns out to be 2. Number 9. Xt is equal to cos 2 pi t. So why am I doing this problem? Because it's similar to this. Why am I doing it? I have said that I want to prove a point. What is that point? The point being that in this case, the ratio will turn out to be irrational, and so it will be aperiodic. You did not calculate the LCM. Okay. So cos 2 pi t and cos 3t. You have already seen that if you do in problem number in discrete time case, problem number I think 5, cos 2n, it turns out to be aperiodic, right? So okay, let us see. No, that was for discrete time case. Now we are doing continuous time case. So in this case, what is the period? T1. 1 second. What is the period?
2 pi by 3.
Yes. 2 pi by 3, right? 2 pi by 3 second. You can see that if I do T1 by T2, what will be the result?
3 by
3
2
by
pi.
2 pi.
So 3 by 2 pi is the answer. But as pi is irrational, this ratio is irrational. So it is an irrational number, which means that it is aperiodic. Answer. Okay. So let us come. So let us finish this. So this is all about what I want to say about periodic and aperiodic. Okay. Now let us go to a new classification. Let us speed up the process a bit. The next is even and odd signals. Okay. So next classification is uh, which number classification is this? 4, right? So 4, even versus odd signals. So write down the definition. So I'm just going to do it very fast. Xt is even,
Sir, not visible. Bodies not
Left side
visible.
of the board.
not visible. Okay, camera. Okay, so just write definition. If xt, the signal xt is even, all of you know this, right? The signal xt is even if x of minus t is equal to xt, right? And it is odd if x of minus t is equal to minus of xt, right? What do they look like graphically? Just write. Point number 1, even signals are symmetric. Even signals are symmetric about the vertical axis. Vertical axis means y-axis. Even signals are symmetric about vertical axis, whereas odd signals are symmetric with respect to, sorry, odd signals are antisymmetric. Antisymmetric, not symmetric. Even signals are symmetric about vertical axis, whereas odd signals are antisymmetric about the vertical axis. Did you understand this point? All of you who are sitting at home?
Yes, sir.
Yes, sir.
Yes, sir. So I'm going to give you an example. Just an so can you tell me whether this thing is even or odd? It's odd because what do
Odd.
you mean by
Odd.
antisymmetric? Whatever is over here, if you put a mirror over here, it will come like this, and you fold it over this axis. So this is just the opposite of this, right? So this is what is called as antisymmetric. So this is odd. Can you draw if this is the so 0 capital T minus T? Okay. So now I'm deleting this. Can you draw the, if this is from 0 to T is like this, what should be from 0 to minus T so that it becomes even? So it's like this, right?
Same as 0 to t.
It is symmetric about this axis. So all of you now can visualize, means if you are given something either even or odd, then you can you can say that it's even and it's odd, right? By observing the symmetric or antisymmetric property, right? So let us go forward and say that, so not all signals are going to be even and odd. There are some signals, let's say like this. Let us say like this, and maybe like this. Okay, this is also a signal, but it's neither symmetric nor antisymmetric, right? Because this over here, this shape and this shape are different, not symmetric. In order for this to be symmetric, you need to have this, right? But here I have triangle kind of shape. So this signal is neither symmetric nor antisymmetric, so neither odd nor even, right? So in this case, there is, but I can do one thing. I can break it up into an even part and an odd part. So just write down this heading: even and odd decomposition of any signal. Any signal means that it may not be by itself, it may not be odd or even. Okay, but I can convert it into an odd part and an even part. Okay, how to do it? So the signal is xt. So let xt has an even part and odd part. Okay. So let xt is even part. For even, I'm writing x subscript e. Okay. X e of t, and x for odd o. Okay. X o of t. So this is even, this is odd. Okay. So I am saying that I can do this. So, but I'm starting with, let this is a combination of even and odd. So then what will be the value of even and odd? Okay. How to find this xe and x0? So let xt is combination of this even part and this odd part. Then what will be x of minus t? Wherever you find t, put a minus. So it will be x e of minus t plus x o of minus t. Right. So now you have two equations, 1 and 2. Can you solve for xe of t from this 2 by eliminating x0 of t? So what will be xe of t if you solve? So let me write, by solving 1 and 2, what will be xe of t and what will be x0 of t? Oh, it's half of xt plus x of minus t. Okay, so this one is half of x of t plus x of minus t. And this one is going to be half of xt minus of x of minus t. You understand? I'm not solving it. You can solve it, right? So these are the results. By solving 1 and 2, you will get this. All of you understood at home?
Yes, sir.
Yes, sir.
Yes. So every signal can be broken down into, so the signal I'm given here is xt. Its even part is this, and its odd part is this, right? So write down an example. Write down an example. Find out the, so example. Find out the even and odd part of the following signal. Find out the even and odd part of the following signal. Xt equals e to the power 2t cos t. This is the signal which you are given. You need to find those components xc of t and x0 of t. These two components you need to find. Can you find? What is the process? You just need to find, so xt you are given, you just need to put to find x of minus t and apply this formula, right? So xt is given. What is x of minus t? E to the power, so wherever there is t, you put minus. Okay, x of minus 2t cos of minus t, right? So so cos of minus t is what? Plus cos t or minus cos t?
Cos
Cos
t
t.
plus
So
cos.
e to the power minus 2t, this is equal to cos t, right? Then you need to find xc of t. So xc of t is equal to what? This, so half of this plus this. So half of e to the power 2t cos t plus e to the power minus 2t cos t. Okay. So I can take cos t common, half of cos t, and take this half inside, like e to the power 2t plus e to the power minus 2t divided by 2. And what is this? Cos hyperbolic of t, cos ht. So this is equal to cos t cos ht. Okay, this is the even part. All right. What about the odd part? XO of t. You just need to put minus over here, right? Here it is minus. So it is half of e to the power 2t cos t minus e to the power minus 2t cos t. Okay. What will be the answer of this? So it will be
Cos
cos
t
t
sine hyperbolic.
e to the power 2t minus e to the power minus 2t divided by 2. It is what? Minus of sin ht, right? So this is cos t sine of ht minus. Okay, so this is the answer. I have found out the even and odd components. Any doubts? Because it's the formula is e to the power minus 2t minus of e to the power 2t for sin ht. Okay. So let us end this meeting over here. So all the people understood?
Yes, sir.
Yes, sir. Yes,
If you
sir.
have any doubts,
Yes, sir.
if you have any doubts, you can ask me, okay? Over WhatsApp.
Sure, sir.
Okay. I'm ending this meeting.